Here's another example where you have ln of x, and you can convert it. You can convert it using u equals to ln of x. And if you exponentiate both sides, e and ln cancel, so you have e to the u equals to just x. Applying d both sides, d of e to the u is just e to the u, but then you have to attach du, d of x is dx. So that means this turns into u over e to the u squared, and then dx is equal to e to the u du. Just check that you don't have any more x's left, because if you still have x, then you have to go back and replace x by e to the u. Alright, I have e to the u here, e to the u, one of the e to the u here will cancel each other, right? So you're going to get integral of u over e to the u du. But this is not good for us because it's a fraction. Fractions are much harder to integrate than products. I mean, the only kinds of fraction I can think of that you can integrate is like things like what f prime over f. What does that integrate to? Ln of the denominator, right? Or arctangent has the derivative 1 over 1 plus x squared. So if you integrate this, you get arctangent tan inverse of x plus c. You can write some really simple looking integrals that are fractions, and immediately it's impossible to integrate. Like if you have sine x over x, this doesn't have an answer in terms of basic functions. It's already impossible. So fractions are harder. It's even worse than products. Therefore, when you have a fraction, one of the things that you should think about is there any way to make it as a non-fraction? Because if it's just a multiplication rather than division, then multiplications can be handled by integrals by parts, right? So we write down this as u times e to the what power? Negative of u. Right? Then this is a product. That means I can happily apply plus minus d integral u differentiates to 1, differentiates to 0. E to the negative u, you integrate this, what do you get? Negative. The reciprocal of this number in front of u comes out, right? But reciprocal of negative 1 is negative 1, so that's why you get that. Another negative comes out, negative of negative is positive. Then you have plus, minus, plus, do this, that. And you get negative u e to the negative u minus u, no, just 1 times e to the negative of u plus c. However, now you have to go back to u, right? So how do you do that? Well, you should go back to u over e to the u, because then you know what to do, right? So let's write it like this. Yes?
Is there a way that we can also factor that out? And factor out the e to the negative u?
Yeah, you can do that, but at the end of the day, it's the same thing. You can factor out, or you can even factor out the negative e to the negative u, right? That would be u plus 1 plus c, right? But then, again, you have to figure out what to do with e to the negative u, and the best solution is to write it as 1 over e to the u. So that e to the u, I know that that's x, and u is ln of x, so that means it's negative 1 over x times ln of x and plus 1. Plus. Yes?
That's due to the natural log. When you raise e to the ln of x, it cancels the e and the natural log out, and it leaves x.
So the question was, how do you go from here to there? And the fact is that
Yeah, you
if you
should.
raise both sides over, so if you take this and put e here and e here,
Mhm.
you end up with e of ln of x,
And
and e and ln cancels, giving you
Okay.
just x.
Okay, cool.
Now, one more thing I want to explain is that when handling e to the negative u, you could try to say, well, u is ln of x, right? So isn't this just e to the negative ln of x? And again, this is not so encouraged because that's a lot more complex than just saying 1 over x, right? So let me show you how to simplify this. The way you simplify this is like there's a negative 1 in front of ln. And if you have a number in front of ln, they can jump over the log like a frog. And I like to call it frog over the log rule. So numbers in front of the log, they jump over like frogs, frog over the log. Yeah. So what do you get? You have e to the ln of x to the negative 1 power. And now e and ln cancels, right? Now it's extremely important that you don't cancel here. This minus 1 prohibits, it gets in the way, and you cannot cancel this, okay? But once it's moved out of the way, now they cancel, right? And then you have x to the negative 1, which is 1 over x. So you get the same thing.